Section 4.1 is Introduction to Hypothesis Testing, and it really is an introduction to all hypothesis testing. This section focuses on hypothesis testing for a population mean, but hypothesis testing is something we'll do in various contexts throughout the course. The whole idea of a hypothesis test, and this is the kind of most fundamental thing to understand, is that hypothesis tests answer yes/no questions about populations. And as the course goes on, we're going to have more and more techniques, and it will be useful to be able to look at a problem and say, well, this is a yes/no question about a population, and so a hypothesis test is probably what I should do. As an example, in 4.1, the question is, we have this context where this machine is supposed to fill cereal boxes to be 20 ounces worth of cereal, and we don't really expect it to always be exactly 20 ounces, but on average it should be. And so our question is, does the machine fill cereal boxes to an average weight of 20 ounces? And this is a yes/no question, right? I mean, yes would make sense as an answer, no would make sense as an answer, but 19.5 wouldn't make sense as an answer, right? So this is a yes/no question, and it's about a population. The population is all cereal boxes that the machine ever fills. And how are we going to answer this question? So we collect a sample. In this example, we collect 100 cereal boxes, and we calculate the sample mean, X bar, and we calculate the standard deviation S. And our question is X bar consistent with a population mean of 20? And initially, this may seem like an impossible question to answer because we don't expect X bar to actually equal 20. That is, even if the machine's working properly, we don't expect every sample of 100 cereal boxes to have an average weight of exactly 20 ounces. But here's the thing. What we do know is we do know that S, the sample standard deviation, should be about the same as sigma, the population standard deviation. That is, S gives us a sense of how spread out the values of cereal box weights are. And once we know that from our conversations about the central limit theorem, we have a sense for how spread out sample mean should be. And so if this value X bar is really far away from mu, by far, I mean in the sense that we have a sense for how far apart sample mean should be. If it's really far away from mu, then this is evidence that, in fact, the machine's probably not filling cereal boxes to an average weight of 20 ounces. And if it's relatively close in the sense that it's not far away in the sense of the sampling distribution, then it seems like we don't have evidence that anything wrong is going on. So this is the idea of hypothesis testing. We want to answer a yes/no question about a population, like this. We collect a sample, and based on what we got from the sample, we ask ourselves, is what we saw consistent with what we are hoping is going on, or with what we're hoping to show isn't going on? Or is it not at all consistent with that? And in this section, it'll be all about the central limit theorem and population means, but in other sections, there will be different details. The underlying ideas will be the same. And so we'll talk about this for a while, but this is the first introduction to it. And so even don't get bogged down in the details. The big picture stuff, the idea of hypothesis testing, is the most important thing about section 4.1.